And welcome back to Mr. Vandrick's stats class.
Woo! Thank you, Charlotte. I appreciate it. All right, so we're going to talk today. Look studious. We're going to talk today about Chapter 12, finding sample surveys. Okay? So, Chapter 11, we focused on understanding the need and how we can use randomness to help us with simulations. What did I prove to you yesterday?
That randomness is important.
Yes? Why did I prove it to you yesterday? How did I do it? Pablo?
Well, I give you one. Humans get explained by different things.
Exactly, especially our own personal experiences, right? So we use randomness to help take that kind of stuff that Pablo is mentioning, which is examples of bias, out of the equation when we can. Okay? So that's the point of randomness, and it's going to be still a tool that we use even when we find samples. So this chapter introduces you to the idea that if we have a population, okay, and it could be, all high school students in the city of Houston. It could be all women in the United States. Whatever the population may be, and we want to find a sample out of that population, we're going to talk this chapter, this week, about what we can do to gather information about that population using a sample. So up until this point, before this unit, any problem that we've done, I've given you the data. But this unit, these three chapters, 11, 12, and 13, are talking to you about how do you initially get the data, right? If we want to know about a population, we need to sample from it, right? Because of time or money, we may not be able to actually get to every person or everything, whatever we're looking at. So that is the reason that sampling became a part of statistics. I am currently in the process of recording this lesson. Shyla gave us the intro. Shyla's you're gonna get us the outro too, don't you worry. All right, redeem yourself. Although I thought you were fine. It was fine. Well, you can say we learned about it. Okay, sorry, not going. It did. From the genie, you get the genie out. The genie is Ignatius. I'm not real sure that's how that works.
No, it's statistic.
All right, let's continue. Now, Pablo, you already mentioned it, and I was trying to prove this to you guys yesterday with our activity about the jelly blubbers. But ultimately, we need to be cautious when potential biases show themselves.
Wait, until you pronounce it?
The plural of bias is biases, yes. Mm-hmm. Now, when we talk about bias, one thing I do want you to understand about this is that there are many times that you will read a sampling method for how someone is going to acquire their sample from a population, and you might be thinking, wow, this might be some bias if they do it this way. All right? So ultimately, the goal of sampling is to get a good representation of the population. You guys remember yesterday, that was the phrase that I said when I wanted you guys to select 10 out of the 100 jelly blubbers. I told you to select 10 that represented all 100. So you picked some big, some little, and some medium. But you guys realized that your brain, whether you knew it or not, was influenced by the size of the blubber. All right, and pretty much as a class, we were drawn to the larger blubbers. Okay, so that's why when we incorporated randomness, the random number table, the average length of a blubber decreased because randomness is not swayed by the size of the blubber. It has no idea what the blubbers look like. You're using the random number table to take yourself out of it. Okay? So we're trying to avoid bias, if possible. Many times, we don't even know it exists. So we use randomness to make sure that if there is bias, that the randomness will minimize the bias and not ruin our results. Pablo.
Can you give us an example, we not knowing that there's bias?
Well, the blubbers was a perfect example because none of us really realized that our brains were showing bias against the small ones. Okay? There will be other ones that come up, I promise. Don't you worry. All right. Now, the next thing that we are going to introduce here, which is something that we've already started talking about, is this need for randomization. Okay? What's great about this is that you guys, hopefully, after doing this for about a week, understand the need and the reason why we randomize when we run simulations and take surveys and samples. But ultimately, the main reason is because it allows us to continue with confidence, even as Pablo was asking about, even if we have no idea if bias is occurring or not. All right, there are things out there we don't know about that could impact our results. So randomness helps us deal with those uncertainties. So hopefully, in this whole process, when you are randomizing, it's a group visiting. Hopefully, when you do this process of taking a sample using randomness, that it will help you get a sample that is a good representation for your population. Any questions so far? Any questions so far? No questions? Okay. All right. Good to listen? Great. Now, on this slide, I'm going to try to use an example here because many of you have probably heard of this word census. Okay, the idea with a census is that you're polling everyone.
Yeah.
I'm sorry? 5 census?
Yeah, the 5 census.
That's different kind of sense. That, right, the 6th sense, right? You see dead people. S-E-N-S-E are those senses. Okay? This is a different kind. This is a different kind of census where you're trying to get information about everyone. Okay, so every 10 years, states and the government for the entire country try to come up with a census to help allocate funding. All right. Now, a census is really difficult to come up with because you guys know, having almost become college students and then soon to be graduates, you guys understand that in life, people move, people change jobs, people die, people are born. So the population is always changing. Okay? It's constantly changing. All right? So a census is very difficult. So what we do to avoid having to get a census every time is we find samples from our population. So I want you to think of this example. I don't do much cooking, all right, but when I cook, I love soup. I love soup. It's my favorite thing to eat. I love it so much. Really, it's more because it's a vehicle for Tabasco sauce, because I love Tabasco so much. But ultimately, I love soup. All right? So imagine on my one burner on my stove, I'm cooking a small pot of soup. Everybody got that in their mind, what I'm doing? Whatever kind you want, Shyla. Okay? I take a spoon, and I'm almost done, and I put the spoon in to taste it, to see how it tastes. All right? What have I just done? I have sampled my soup. Now, this is where students' brains have a little trouble, so listen to what I'm going to do now. Now imagine, instead of making the soup for me, I'm making this soup for 100 people. Okay? So instead of one burner with one little pot, I've got a big burner with a massive pot. Like the biggest pot you've ever seen. You could put a person in it. Don't do that. Okay? So now I've got a big pot of soup. Do I need a bigger spoon to sample it?
No.
No. And that is the whole idea behind the idea that it's the sample size that matters, not the size of the population. So I'm going to repeat that because you're going to hear that a lot from me. It's the size of the sample that's important. It's the size of the sample that's important, not the size of the population. It's the size of the sample that's important, not the size of the population. Yes, so my spoon didn't need to change. My sample didn't need to change, even when my population changes. It's all about the size of the sample. That's all that matters. No, what I'm saying is most students, Bashir, think that if I have a bigger population, I need a bigger sample. That's not necessarily true.
You don't have Sam's have a bunch of samples. I literally got a whole day one time just walking around.
Did you feel bad about stealing from Sam's?
No, you don't
No?
see it. It's not.
Okay.
Costco.
All right. Let's talk about some population parameters. Now, we have spent, come on now, that's not that bad. We have spent some time talking about some of these. You guys, do you see Y bar and mu? That's our statistic and parameter for the mean. So anytime I talk about a population mean, I'm going to use mu. Anytime I talk about a sample mean, it's going to be Y bar. So the notation matters. If you are reading something in statistics and you see notation like this, the person who wrote it is telling you if it comes from a population or a sample. So I tell students to think about alliteration. Do you guys know what alliteration means? Like using the same sound over and over again? No? Like, I mean, yeah, okay. Like Peter Piper picked up, yeah, that one. I don't know. Okay. There it is. Thank you, Chris, for the win. Woo! Now, that was very nice. When I think about alliteration for this, the reason I bring it up is because I want you to think population parameters. Repeat that. Population parameters. Sample statistics. Sample statistics. That's the alliteration, okay? So think about that when you're like, which one goes with which? It's all about the same letter. So we don't have that when we talk about populations. We have parameters. Because if you're talking about statistics, it's probably come from a sample. Okay? So that's how the notation here. My personal favorite is this one here where it's the population proportion, and it says P, pronounced P. I thought that was pretty hilarious, but that's just me.
Oh, really? I thought it was pretty like EXD.
That was Shyla, by the way, assaulting Natalie. All right.
Do I say restraining order?
Sigma? We should know sigma. That's the population standard deviation.
Okay, so.
All right. Now, the last part of this lecture is going to be about the different type of samples that you can run. You will be quizzed on this on Friday. I repeat, you will be assessed on these different types of sampling on Friday. All right. So the first one you should know, which is actually something that you did yesterday, is a simple random sample. So anytime you see the three letters in capital SRS, that stands for simple random sample. SRS, simple random sample. All right? So the most basic one I can think of, if I wanted to get a sample of students at Cristo Rey Jesuit, I would find all of your ID numbers. Right? You guys all have a student ID number? Yep. Out of 550 students, I would randomly select 50 based on your ID numbers. That is a simple random sample. Can anyone see any potential issues with doing that kind of sampling?
Yes.
What kind of issues, Chala?
The first fourth part is and the last is
So when I'm taking 50 students out of Cristo Rey, my sample, out of 550 total students, that's the population. If I just use an SRS, I think what your brain is getting at is you could end up with mostly one class. Let's say you have mostly freshmen or mostly seniors. And whatever I'm asking those students, your opinions about my questions might be different if you're a freshman as opposed to a senior. Okay? So simple random sample, it is perfectly fine to run, but I would say that most sampling agencies out there in the world don't run only this because it has a lot of limitations. Pablo. Okay. Thank you for letting me finish. All right. Now, one thing I do want to mention before I move on, anytime we take a sample from a population, and then I do it again, and then I do it again, will my samples always be the same? No, think about that example with the students at Cristo Rey. If I sampled and got 50 Cristo Rey Jesuit students out of 550, and then I did it again, am I going to get the same 50? Probably not, and most likely, I'm not even going to get any of the same 50. Okay? So that difference in sampling is called sampling variability. That's not a bad thing. I don't want you to think that because we get different samples that it's a negative. It's not. Okay? So it's not a bad thing. That's not a bad thing. Good question about repeating. If I did get a repeat, and I'm thinking about each student ID number is for a unique student, I'm going to have to ignore repeats. Right? Remember yesterday when we ignored the repeats for the blubbers? Because each number was for a unique blubber. So in that case, I would have to say, if you get a repeat, ignore it, get a different one. All right. Let's go to the next slide. The next kind of sampling strategy is called stratified. All right, and there's really two that I want to talk about here. Stratified and the one on the next page is called cluster. All right, I would say in teaching this for 8 years, this is the hardest difference I've seen for students to understand stratified versus cluster sampling. All right, so I'm going to wait till you're all done writing, and I'm going to give you my, hopefully, best example for you to understand the difference. Because again, you will be asked, what kind of sampling strategy is this on Friday for a quiz? Yes? Well, the first part is going to be giving you scenarios, and you have to tell me what type of sampling strategy. So simple random sample, stratified, cluster, and then we've got a couple more we're going to talk about today. Systematic is another one we'll talk about. And then convenience, I think you guys might know what that means. That just means what's convenient for the person running it. That'd be like, you know what? I want to know some information about students at Cristo Rey. So I'm just going to go to the front of the school at 7:30 and ask the first 10 kids who show up some questions. That's convenience sampling. I didn't randomly pick any of those students. I just went and said, hey, do you want to answer some questions? That's convenience. There's a lot of issues with that too, because that's not random at all. Okay, so you guys ready for my example about stratified versus cluster? All right. So my brother's getting married on Saturday.
Oh, are we
All right. You're not going. My older brother's getting married on Saturday. Okay. Older brother. I beat him. I beat him. 2 kids to 3 kids. Okay. Winning. He's 34. He's 2 years older. Correct. But my little brother actually got married first. What? Okay. He beat me, I know, right? Yeah, but I beat him to kid number 2. So, and 3. Okay. Hashtag who's winning. Okay. So on Saturday, at the end of the night, there's going to be delicious cake. Okay? I can't wait to eat it. I have no idea what it is, but I love wedding cake. It's magical. It's sad. Okay. So you guys picturing the wedding cake, right?
Yeah.
Okay. Imagine that that's not me. My brother and his soon-to-be wife are going to cut into the wedding cake. Okay? And they're going to end up serving pieces to the guests. Okay? Each of those pieces is called a cluster. And here's why. Okay? It's a cluster because it's a mini population from the entire cake. If the cake has cake and frosting, what does each piece of cake have? Cake and frosting. So it's a mini population. So think about that when you're thinking about cluster sampling. It's a mini population. If you think, oh, that sounds like a mini population, that's a cluster sampling. Okay? Here's stratified, and then this might help Diana. Here's stratified. Imagine that before they cut the cake, I want to do some sampling from the wedding cake. Okay? I'm not going to do this. I'll be asked to leave. So I decide to take a little bit of the frosting and eat it. Okay? Then I decide separately, take a little bit of the cake and eat it. Okay? Whenever you sample by taking a little bit from each group, that's called stratified. Okay? So if you have groups, let me give you an example about increased array students. What if I decide, remember that method I just told you about, SRS? And I said 550 kids in the school, and I randomly select 50. Yes?
Yes.
Now what if instead of doing that, I decide to break down increased array Jesuit into 4 categories? Freshman, sophomore, junior, and senior. And then I sample 10 from each class.
That's stratified.
That's stratified, Diana. You got it. That's stratified. Sampling a little bit from each. Now watch this. Watch this, Pablo. Watch this, Pablo. What if I do that, break it up into freshman, sophomore, junior, and senior, and I decide to randomly select all the sophomores and sample them?
That's cluster.
That's cluster.
Wait, so
No. So cluster is when you take one
for one specific.
group and you do all of it. Okay? Stratified is a little bit from each group.
So stratified is like a strategy, and as a strategy, you're going to take each of them like equally.
No, because cluster is also a strategy. Just
Okay,
different
but,
strategy.
Are you going to take them equally on stratified while the cluster is?
I don't want you to think stratified must be equally. Think stratified as you have groups, and each group is a homogeneous group. So there's some characteristic about that group that makes them the same. Like they're all freshmen. They're all freshmen. They're all sophomores. They're all juniors. They're all seniors. Wait, listen. So now if you think about cluster sampling, if you take freshmen, sophomores, juniors, and seniors, and I take all the sophomores, that now has become a mini population of increased array Jesuit because I've taken all of them. That's a cluster. I know it's super weird because it seems like it's the same, but it's not. This is why it's hard. Shyla, then Lily.
So can't stratified turn to a cluster? Because like, you know, you said you take a sample from each, so like sample baby, sample from mom, sample from dad, plus baby.
Well,
I don't think it goes.
I'm not real sure that's how that works when you make a child, but I don't know. I'm not a doctor. I think what I would tell students is just think about what they're saying in the problem. Are they taking a little bit from each group? That's stratifying. If they're taking one group and they're doing all of it from that group, that's usually cluster. So like, think of it.
Can you give another example?
Yes, when we do an example. How about that? Because I'm almost done. All right, so write down cluster, because we're almost done. We're almost done. We're almost finished. Almost finished. I know you will be. It's okay. Stratified?
Stratified is each from each group, and then cluster is just only one group.
That you got it. If you focus on that, Pablo, I think you'll get the question right every time. Stratifying is a little bit from each group. And think of like clusters. Your clusters are mini populations. So if I take one mini population, that's a cluster. It's okay. We're going to do lots of examples, guys. Yeah. What I say usually about. Oh, well, I'm just saying, like, there are instances where they can try to confuse you. I'm going to try to keep it straightforward right now, Bashir, and then have the questions get more challenging as we go. So we're going to do an example soon after we finish this. We're almost done. And I can show you what I mean about the confusion that happens when you read an example. All right? It's the first time. You guys are all good, right? Quiz Friday. Plenty of time. Yeah, Shai.
Stratified by which grade? So say you cover that one.
So again, it doesn't matter how you stratify. Stratify just means that you've separated them, Shyla, by a characteristic. It can be by clothing.
Doesn't that turn to a cluster?
It's how you sample is when it becomes stratified. Or if you say, I'm going to take a few students that are wearing black shirts, a few students that are wearing red shirts, a few students that are wearing green shirts, that's stratifying. If I separate you by color of shirt, I say, I want to take all the green shirts and sample them. Now it's become cluster because I'm only taking one. But how you separated them depends on what you end up doing. Does that make sense? Okay.
Okay, so well, like here in Crusade, like we do the prides and stuff.
Oh, yeah, okay, great, yeah.
So like it's like
That's great. This is a good example. Listen, you want another example?
So we have like the communities. We all have different community members.
Yeah.
So it's like that one community member.
What's your community number? Do you know?
Mine's 5.
So you're senior 5. Got it.
Senior 5. So it's like senior 5, sophomore 5, and junior 5. Like
That's how it is. So if I were to sample by taking 3 students from senior 5, 3 students from junior 5, 3 students, you see where I'm going with this? That's stratified. If I decide to take all the students from junior 5 and sample them and not look at any other 5s, that's cluster.
What if they just chose like
Nice work.
all of the 6?
You are now the teacher. It doesn't matter the number, right? It could have been a different number.
I feel like it's different because it said only junior 5. What if I'm taking freshman, junior, sophomore, senior, only junior 6? Or like only junior
Yeah, that's fine. That's fine. It doesn't.
Cluster?
Yeah, as long as if you're taking all from one group, again, this guy, all from one group, that's cluster.
Just open that. And then close it.
What does he need?
Like 3 from my group.
That's fine. Let's do one more slide. Bashir, sorry.
I don't get it.
We're gonna. Ooh, good question, Bashir. The moment you take, I would say that the way they usually do sampling methods is they don't do partial ones. They either say, I'm going to do full-on cluster, and they're going to do all of one of those groups, whether it's freshmen or juniors, and then they're going to say, oh, you know what, I'd rather do systematic and get the thoughts from a little bit from each one. Does that make sense? That's a really good question.
Wow. You should take a picture.
Take a picture of what? Of this? Well, he'll be here in 20 minutes. So, all right. Let's talk about the last one. Now, this sampling method called systematic sampling is actually, if you've ever been to the airport, this is how they randomly decide to search someone.
Is that what they do in prison right too?
I don't know. I'm not.
And they do the little red thingy. They make it in the red letter
Sorry, bro. I'm not a part of that. If they were to ask my opinion, I would breathalyze everyone that showed up. It can't be that hard to be like, blowing this. Done. Okay. Exactly. But that's part of the deal. So, what I would say about systematic, if you've ever been to the airport, the way that they do it with the TSA at the airport is they randomly select a passenger. Okay? You know, they have a list of all the passengers that should be coming through the airport that day. Yes? Have you guys ever thought about this?
Really?
Yes. Airports have a list of passengers that have flights booked for that day. Okay? And it's someone's job to do this. So they will randomly select a passenger. Okay? So say they pick me. All right? So when I show up, they're going to search me. Okay? Pull me aside. Yeah, search my stuff. There you go. Now, what they do to make it systematic is they search me and then every 9th person after me, or every 50th person after, or every 100th person after. That's systematic. So you randomly start somewhere, and then you go every however many after that, you do it.
The one that we did, the 20 after 20 likes.
No, it's a little different, but ultimately I want you to think about whenever you see that phrase, sample this person, and then go every 11th person after it. That's systematic. That's systematic.
Like you start somewhere with a pattern.
Exactly. You randomly start somewhere. I don't want you to think randomness is not involved. It is. You randomly start somewhere, and then there's a pattern consistently going forward. So every 15th light, I'm going to check to make sure it's working. That kind of thing. Okay? Because I don't have time to check all the lights. Pablo.
Let's say pilot pick number 10.
Great.
And they keep on going 15.
So every 15th? Every 5? Okay.
So then it will be 5, 20.
So it'll be 10, 15, 20, 25, 30.
And
Yeah.
if you were sitting in the 13, you wouldn't get.
I won't get picked.
Okay.
Yep. All right. Well, we're going to see. We're going to do an example real quick. All right. So